Cool. All right. Welcome, everybody. I know 9 a.m. is very early after a fun party last night, so appreciate you coming. My name's Jim. I work at Yelp as an engineering manager. I also teach at UC Berkeley a couple courses. And today I wanted to talk to you about how we're doing the migration from a hosted data center to the cloud and some of the lessons we've learned. The process is not complete and may never be complete. But I think some of the things we learned I'd like to share with you and then hear your perspectives and your questions. I think we'll have plenty of time for questions. So the first question is why the cloud? I want to answer this, why and how Yelp is moving to the cloud. What are some of the things that we're doing, some of the tools we're using, and the pain points. I'm going to try to make some general points and then dive into some specifics for how we're solving those so that you guys can get examples of those problems. You guys might solve these problems differently, but I think it's important that they get solved somehow. So for those of you who don't know, actually I'd be curious, who does not know about Yelp? No? Okay, all right, so I can skip this slide, great. So, although I will say if you guys have a chance here in the Venetian checking out the Bouchon restaurant, I used Yelp to find it last time we were here. The chicken and waffles is really good, right? But don't go tomorrow because that's when I'm going. So Yelp data you may know less about. So we have around 250 gigs of compressed logs per day, and that's over all of the different ways that we do logging, from advertising logging to the website logging. And then we have around 7 terabytes in the database, and more than that in secondary storage. Secondary storage is kind of the storage in S3, which I'll be talking about a little bit, and it's the data that we generate by combining, mixing, making models, summarizing user behavior, that sort of thing. And as you can see, we're growing very quickly, and so that's one of the themes we'll be talking about is the flexibility moving to a cloud architecture provides. So in general, this is kind of my main point of the talk here, is that the cloud, why we're moving to it, the cloud offers this trade-off between specificity and optimization for a specific use case and generality or abstraction, a way to leverage the technology that's available in the cloud so that you can move faster and do more things and be more innovative. And in many ways, I think it's similar to open source. When you choose to use, say, an open source package versus building something in-house, right? The open source package is never going to solve your needs specifically, but that doesn't mean that every time you need a web server, your team needs to go out and build one themselves. And just like Apache or Nginx will let you serve traffic more easily and focus on your core business, a lot of times that's what the cloud offers, but you need to make sure to make that trade-off. And that's one of the other things. Like the cloud is not just a checkbox to say, hey, I'm cloud ready. It's something to solve specific problems for, and that's what we've used it for. I want to talk about some of the specific problems that we solved. So one of the ways, the way that we moved to the cloud is obviously why I'm here. We use AWS instead of other offerings. AWS had been the kind of default standard, and when we've looked at alternatives, there wasn't a really strong, compelling reason to move yet. But hopefully these points apply more than just to AWS, right? There might be offerings in the future that are more compelling, so we want to keep those options open. The main component that we've moved over to cloud is our batch processing, and we moved that over to EMR, Amazon's basically Hadoop, hosted Hadoop solution. And instead of running Java, writing Java code, our developers have been writing Python code. And so we built an open source library called MrJob that lets us write in Python and then have MrJob as a library spin up these clusters, run the Python code, copy over all the libraries we need, set up bootstrap actions, all that sort of stuff. So developers can focus on the code that they know, use the libraries that we have, instead of using something completely new. But that took a while for us to build up, and I'll talk about why we built that up as well. So I want to flash back to the past. It was 2004. Little John was saying, yeah. And the typical lamp stack was what we were using at Yelp to run all of our traffic. The P there is for Python. Like I said, we're mostly a Python shop. And we were hosted in a data center, just like many other people at the time. And the cloud wasn't as big of a thing yet. And so when we started doing logging, I just want to talk about this for a sec. Logging was beginning to be really important for us. So one of the things we did fairly early on was move to a structured format for logging. And our structured format happens to be JSON, but I think in general it's really important that you guys use some sort of structured logging that's very easily machine parsable, where you don't have to pass around code in order to parse the different ways you might be logging. And in general, my recommendation for logging is every time you show a web page or do some action, every ID that potentially appears on that page should also appear in your log, so you have a really good idea of what was going on in that page. The example here is a hypothetical search query log. And in it, we have the user ID that made the request, what the terms of the search query was, but perhaps most importantly, the results that were returned from that query, what business IDs were returned from that. And from those business IDs, you could calculate things like click-through rate, relevance, all that sort of thing. And if you don't log those, you may know that farm to table was a popular query that month, but you won't know what businesses showed up for it or what people ended up clicking on. So making sure to log all of that information is very important. The exception is personally identifiable information. And we'll talk about why that is in general, but you want your logs to be accessible to as many people as possible. And if you put in PII info, you limit the number of people, the number of ways that log can be used. So instead, what I recommend is, again, sticking to IDs. So put your PII in a database. And then in the log, you put an ID that kind of points to that database. And in the future, if you need to join against PII for some analytics reason, you could do that in the future without polluting your logs that way. Just like you don't want to store, say, credit card information in a general log. So some of the trade-offs we made for Hadoop were when we moved to Hadoop to do this log processing, the Hadoop was obviously just in Java. And we needed to decide at the time whether we were going to kind of write our own version of a MapReduce paradigm or stick with some existing open source solution. Again, that's kind of the trade-off that you make, is figuring out whether you want to leverage an existing technology or build it in-house. And we also had to train up a lot of our developers on this concept of MapReduce versus kind of having global knowledge. A lot of our batches assumed that they could aggregate a lot of data together, access all parts of our infrastructure in any way that they wanted, and we're running on a single machine and can kind of see all the data at once. And so this is another example, and kind of in the same vein as making that cloud trade-off. We wanted to process terabytes of logs, so we had to give up some of the things on the right-hand side in order to be able to distribute these jobs more easily. So we built up the Hadoop cluster we had, and it was working really well. So I have a riddle. When do you know your solution is working very well? Right? When do you know you've had success in your infrastructure? And I think one interesting answer is it starts failing. So failing is a great example of success. And the reason is now you have too many users using your solution. And this is exactly what happened at Yelp. We had Hadoop. It was working fairly well. But people were starting to complain and experience problems because we were so overwhelmed by the number of things that people wanted to do. And some of those issues specifically were failures correlated with cluster time. So if we ran a Hadoop cluster for a long amount of time, we would see memory leaks, we would see other issues, and eventually that cluster would slow down or break in very weird ways. And when we wanted to launch new features that depended on doing this log processing, we often had to coordinate with other teams. So we had to say, oh, are you using the cluster right now? Or what time are you using the cluster? I want to have this new feature, and it's going to involve 3 or 4 days of backfilling data. Is that OK? And that slowed down the pace of innovation. It slowed down the ability to teams to kind of roll out features as they were ready for it. And finally, I'm sure a lot of you guys know, upgrades were fairly painful. So bringing the whole cluster down, again, scheduling with other teams for when infrastructure upgrades could happen was one of the pain points that we experienced there. So with all of these problems, we wanted some specific solutions. And when we looked at EMR, we found a lot of these solutions. And that was the reason why we decided to migrate. So clusters were up for a limited amount of time, right? You spin up a cluster to need it. It shuts down when you're done. You don't have to worry about running it for a really long period of time. And you kind of get rid of this problem of accumulated memory loss, accumulated memory leaks. Upgrades are obviously handled by Amazon. And again, you didn't have to bring down a cluster because you're bringing up and down a cluster all the time anyway. And multiple clusters meant there was no capacity coordination. So when a team needed to do a backfill, they would spin up their own cluster entirely on their own and not have to work with other teams to see if their cluster could handle the extra load. So when we moved to Hadoop, my question for you guys, to move to EMR, my question for you guys is, are these good trade-offs to make, right? We want to trade off specialty knowledge of Hadoop for specialty knowledge of EMR. And we want, instead of coordinating features for launch, we wanted to coordinate code deployments to the cloud to figure out, say, which version of the code or libraries we need to move to the cloud. And instead of testing on our local cluster and pushing code to the local cluster to see if it worked, we wanted to push code to EMR to see if it worked, right? Are those good trade-offs? Who thinks those are great trade-offs to make? One person? A couple people? You're wrong. Sorry, not to point you out. Thank you for participating. No, these are not good trade-offs. You're trading off basically the same things in each area, right? And we didn't want to make these same trade-offs. We didn't want to spin up developers in just another different technology and saying, hey, you don't have to learn this Hadoop technology, but you do have to become experts in this other area. We did not want to do that. We wanted to make it much easier and actually build tools so we could leverage this extra capacity, extra ability to use cloud architecture. And so the trade-offs that we wanted to make and the trade-offs that we eventually did make, we traded off the specialty knowledge of Hadoop for standard configs in EMR. Standard ways people could spin up clusters so they didn't have to worry about what cluster size should I be using, what configuration options should I be using in that cluster, what bootstrap actions should I make in order to be able to work with large amounts of data or large amounts of CPU capacity. Instead of coordinating for feature launches, we just wanted to track resource consumption instead. So what we were saying is, hey, we don't need you guys to coordinate with each other, but we do need to know how much capacity we're using so we could plan for budgets and to make sure that people aren't wasting resources when they might be able to do something better. But that's more of a trust and verify model than a ask me for permission model. And finally, testing on a local cluster, a local Hadoop cluster and having to push production code there just in order to test it. Instead, what we did was in MrJob, allow people to test locally. So on their own laptops with a subset of data, people could test their algorithm, test to make sure it worked before pushing that code to Hadoop. And we additionally do some testing on Hadoop itself to make sure our general libraries work, that any low-level changes we made to, say, MrJob are continuing to work over all of the batches we run. All right, so I want to discourage this notion of cargo code, of trying to pretend like you're cloud ready, but not actually taking advantage of any of the things that the cloud provides. In order to really maximize that leverage, you need to make sure that it's very easy for developers to use it and that they're doing the right thing. And so let me dig into some of these specific examples. But remember, hopefully these are general lessons where, for example, this standard configs is whatever technology you guys will be using, you don't want your developers to have to worry every time about what configuration they should be using. So the way it works with MrJob is that there's a standard configuration file that all people use. And when a cluster is spun up, it picks the bootstrap actions that install common packages and push a particular version of the Yelp code base that is standardized across all production builds. When you launch a cluster, MrJob copies a tarball to EMR, expands it, and then sets up the correct Python environment so all of those libraries are available. And the configurations we have are a standard one that's great for most jobs, a memory-intensive one where we expect, say, reducers to accumulate a lot of data in memory before being able to process, and then a CPU-intensive one that allows people who need a lot of raw CPU power in order to power through their jobs. And this is a small subsample of the configuration that we use for MrJob. And as you can see, for example, for the standard jobs we have, we use 5 M1 larges. For a memory intensive, we use M1 extra larges, 12 of them. And we have some additional bootstrap actions that set up a swap partition as well as use Amazon's standard configuration for Hadoop to increase the amount of memory available to each reducer and mapper. And then finally, the CPU-intensive job uses C1 extra larges. As another kind of side note here, we did some playing around with these numbers to make sure they were kind of generally optimal. One of the things that we saw, which may have changed over time, is that actually increasing the number of machines that we use, for example, 12 M1 extra larges, was still more efficient latency-wise than using, say, M2 extra larges or 4x larges or something like that, because the number of machines allows you to suck down data from S3 in parallel much more easily. And so the way we do resource tracking, as another example, is using a side utility of MrJob, which checks the jobs that are currently running in EMR and how long they've been running. So if something's been running over a day, the general Hadoop list gets an email saying, hey, are you sure you want to be running this over a day? Because that is in our environment, that's fairly uncommon. For you guys, it might be different. We might want to do something else. And another way that we make sure that we don't kind of have runaway jobs is MrJob has another utility that looks for idle job flows in EMR, job flows that are not doing anything right now. And it'll terminate those after a certain period of time. It'll actually terminate them close to the hour mark, so potentially if someone wants to reuse that cluster, we're able to. And then in general, when MrJob is pushing up new job flows, it'll label them by the developer that's running the job or the specific batch that's running. So when you look over the usage of EMR, you can associate different batches with teams and understand how much resources each team is using. And finally, for testing, MrJob has this local mode. And you actually run it in the exact same way that you'd run it in EMR. The only difference is you specify a runner. So there's a local runner and an EMR runner. You invoke it in almost the same way, but the local one will run on your laptop, and you can use standard Python tools to debug it. So you can insert debugging statements, do backtraces, and get a little more insight into what's going on in your job before taking the time to spin up a large cluster and process a large amount of data. And then the infrastructure is tested with what we call MR Canary. It's a small job that almost does a no-op in the cloud, but it makes sure that all of the standard libraries that we'd like to be using are loadable and available. And again, that's to make sure that the whole process of bootstrapping a cluster and pushing code works for us. So I do want to say MrJob is open source if you guys are interested in using it. It's on GitHub. It does include support for other languages. So there have been folks that I've met here actually that are using it with Ruby. You can mix languages together and have some Python and a jar file to process your data. And it includes this cluster management I've talked about for terminating job flows, checking for resources, and that sort of thing. And you program in it in a MapReduce paradigm. So you specify potentially multiple mappers and reducers. MrJob will string those together, create temporary intermediate directories to string together your data. So I'm going to change directions a little bit and talk about adoption inside the organization. So once we have these tools ready, how do we make sure that developers were using it in the best way, we're leveraging the technology in a way that made use of all the benefits? And one of the themes I want to emphasize here is it's important for you to make the easiest thing to do the right thing to do. So a lot of times you'll have developers, again, who are very focused on just getting their new feature out. And what you want is for them to say, how do I do this? Find the easiest way to do it, and then for that to be a way that works really well in your infrastructure. If these are not aligned properly, you're going to find many cases where you're going to have to harass developers to change what they're doing in order for it to fit into your model better. So one of the things that we had to educate people somewhat fairly early on that's been talked a lot about in this conference is this concept that running a batch for 5 days with 10 machines costs roughly about the same amount as running for 1 day with 50 machines. So of using basically more resources to get your job done faster. And since you're billed at a machine hourly rate, that cost is essentially the same. And I say essentially because there are differences if you're using spot pricing or reserved instances, but those differences usually don't cancel out the fact that you're getting a lot of latency benefit from using more machines. And so in that example I showed earlier of finding jobs that were running for over a day, a lot of times what we tell developers is, hey, are you doing a backfill that's taking a long time? Just increase the number of machines and get it done faster. And so making sure to communicate this across your org is important. One of the things that I think a lot of people think about, but that actually Yelp doesn't think about too much is cost. And I hear a lot about trying to calculate whether something is better run in the is cheaper to run in the data center or cheaper to run in the cloud. And for us, we don't really think of it that way. I think the cloud offers, as I say, the cloud offers infrastructure here that is basically impossible to run in a data center. So there are some movements to have private clouds where you can run the same sort of infrastructure, but I've never seen it done the same way that you can do in the cloud. I've never seen this last slide really true in your own data center. And so what we're really looking at, what we're really considering is how much flexibility, how much innovation are we allowing our developers instead of which is the cheaper to run. I think it's comparing apples and oranges mostly, and therefore we don't try to do a lot of calculations as to what works better. We use the cloud because it allows things that are not possible otherwise. And one of the other things to consider here is you're not just paying for hosting, right? When you're using EMR or other things, as you've seen in this conference lots of times, you're buying development for other features that you can use in the future. And now this slide is out of date because there have been new things launched. And I think that's really important to consider. The cost you're paying, again, is going toward new features that your organization can use without having to maintain them yourself. But I don't want to give the impression that we don't care about cost at all. We have done some work in order to keep costs down or keep costs reasonable. EMRio is a tool that we wrote that looks at your past usage of EMR and tries to calculate how many reserved instances should you have bought in the past. And for this is a good way to estimate capacity in the future. You could imagine an even more sophisticated tool that tries to predict the ramp of how much you will be using so we could buy for that future. But we found that that kind of risk isn't worth the reward of any extra savings. So we basically look retrospectively in the last 3 to 6 months, how much were we using, how much reserved instances should we have had, and then we go ahead and buy those. So MrJob also allows job flow reuse. So one way to do things is to spin up a cluster and then shut it back down after the end of a job. Another way you could do it is to spin up a cluster. When that job ends, if you're not at the end of a billing cycle hour, another job can kind of sneak in there and reuse that same job flow. There's some trickiness to how you do it. You have to make sure that the new job wants the same number of instances, has the same version of the code available, all that sort of stuff. MrJob handles a lot of that. And for more information, you can see an article I wrote on highscalability.com that talks more about these ideas more in depth. And so finally, one thing to make sure that people could use cloud technology is being able to have logs, production logs, available to as many people as possible. And so in general, our production logs are available to all developers. If they want to write a new feature that uses, say, user activity, they're free to immediately start testing hypotheses on those logs. The development environment exists with separate permissions. So developers aren't writing their output to production. They're not overwriting files or deleting production files. But for those logs, they are available for developers to use. And then additionally, to make more data available, to make MySQL data available, which is where we keep our OLTP data, we have a S3 MySQL dump project. Very simple project, runs MySQL dump either on the full table or incrementally as an option, and uploads that data to S3. And the data in S3 is made available to EMR jobs as well, so you could do things like join log behavior against MySQL data. So kind of putting that all together, you can see a general layout of how we work. On the bottom, we have some of our hosted resources, the web servers that are still serving traffic in our own data centers, and the databases, which are also in our own data centers here. And from our databases, we can upload using S3 MySQL dump data into S3. And for the web servers, we use Scribe to aggregate data and then upload it into S3 at the end of the day. We use EMR with Hadoop to process that data, again, make derivative versions of the data, join against MySQL and user behavior, and create models, summaries of user behavior, analytic queries, that sort of thing. And what we produce out of those is often JSON. Sometimes we also produce MyISOM files that we then sync back down to the databases in order to, again, serve traffic, serve derived data or analytics to customers. So it's not all unicorns and rainbows in the cloud. I want to talk about some of the pitfalls we've encountered, some of the problems that you might run into. So for leaky abstractions, one of the main things that we've seen as a use case of this is this read after write consistency, or the eventual consistency of S3. Even in what are called consistent zones of S3, that consistency is very, very limited. It's limited to a get after a put of a specific new object. So it does not include things like list. It does not include things like overwriting a file and being able to immediately see the new version of that file. And so we encountered this problem that we would upload scribe logs to S3 and then immediately try to process them with EMR. And that directory would suddenly not have any files in it, or have a subset of the files that we expected to be in there. Earlier in the talk, earlier in the conference, I was talking with some Netflix guys, and they've tried to solve this by going to DynamoDB to keep track of metadata information. The major way we've solved this is, frankly, just waiting longer for the consistency to get up to date. Closed source is a concern for us. With Hadoop, it's been very easy to look at the source, see what's going on. But when we encountered a problem that used some of the source code that Amazon provides, specifically uploading the result of Hadoop jobs to S3, we were encountering a problem where we'd see files kind of partially overwritten or empty. And what this turned out to be was Hadoop's speculative execution, where if a particular map or reduce step was taking a long time, it would try to spin up another one. And what would happen is both of those would try to write to the same S3 bucket, S3 key rather, and you'd get inconsistency at the key level. You'd sometimes get an empty key there because of some of these issues. And for us, it was almost impossible to debug because we couldn't look at the code which was actually doing the uploading. So it was very hard to narrow down. And we had to work with Amazon's help desk in order to track this down. And going back and forth across two organizations can be much slower than one team investigating a problem. So Amazon would often say, oh, I think we fixed it. Can you run a bunch more jobs? And since this was an intermittent problem, I think it ended up taking 2 or 3 weeks to actually resolve. The solution, by the way, and I think this has been propagated to standard Bootstrap actions, but is to turn off speculative execution in Hadoop here. And finally, as we've been using this technology more and more, we've kind of exploded the number of data sources that we've had. And when we do uploads of MySQL, uploads of that information, we need to keep track of which is the newest version, which version should people be using, which is the most up-to-date, when are logs available that have been uploaded from web servers, and doing dependency matching in there. Right now, we use a system called Tron, which is another open source project that Yelp develops, kind of like a distributed cron that manages dependencies and scheduling. And so that has helped us so far, but I don't think this problem is fully resolved. We're thinking of other ways that we want to semantically tag information that's in S3 so that all developers can understand what's there. In general, this is something I've wanted for a while. I've talked with some of the people here at the conference about it. But what I'd like is to see better integration between these different data models so that it's very easy to, say, use Redshift, Dynamo, MySQL all together, and to have these different systems have the same data in them, but be able to access it in different ways. And so Yelp is thinking about how to put this sort of system together. I know several other companies are as well. So next up for Yelp is services. So now that we've moved over basically all of our batches, we're thinking about how to move over individual services into Amazon. And again, we're taking the same method. We're trying to figure out how can we increase developer productivity so that they don't have to wait for 3 months for a new rack of servers for a somewhat experimental new service. We want to experiment with new ways of hosting, for example, in Docker, or using Dropwizard for new Java services. And we'd like to do that in a very easy way that developers do not have to coordinate with other teams, including the operations or infrastructure teams. And so I think that sounds very similar to what we were trying to do with our batches. And so we're using a lot of those same techniques. So we're making sure to target a specific problem we're trying to solve. which is increasing developer productivity, decreasing coordination costs. We're trying to make sure that we make the right way the easy way so that developers are able to spin up services as easily as possible, but make sure they're distributed, they're resilient to individual box failures, and they're making good technology choices. And we're trying to leverage the existing technology that is out there for hosting services in order to make these new services really easy without developing those technologies ourselves. So in order to do this, in order to have both a web service hosted in our own data center and services hosted in EC2, we're using this generalized packaging format. For example, using Python eggs to package up all of our libraries. We're looking at Docker and Packer in order to package up services for deployment both in the cloud, and as we talked about, local testing is really important to us. We want to be able, for developers, not to have to spin up and configure a cluster just in order to test a new idea. And having Docker and Packer allows us to do that. For deployments, again, making deployment the right way, the easy way, we're looking at Netflix Animator and doing some Jenkins testing before actually doing that deployment. And finally, to make sure that we have a great connection between our existing data center and AWS, we're using the Direct Connect. So finally, if you guys are really interested in this, we are hiring on basically all teams, not just infrastructure. So if you're interested, please check out yelp.com/careers. I am here available after the talk, as well as some of my coworkers here in the front row. So thank you very much for your time. I think we have plenty of time for questions. If you have any, I'm happy to take them.